So we've done a little bit of a progression today from kind of the basics of the technology to now we're going to have the vendors come up and talk a little bit in detail from their perspective on the technology as a prelude to the demonstration. So we've got for the next 45 minutes before lunch, we've got Robert Tabera, CEO of Airsight, and he will explain this in detail and correct me to 100%, but Airsight is essentially an integrator of technology, and they are the ones that work directly with the Department of Corrections, and they come and they're your interface to install and maintain the equipment and use through their technology and interface. We've also got David Lewin from Echodyne, which is a radar manufacturer, and that's a component of the Airsight system. So you're going to get a perspective from the integrator and some of the component manufacturers. And so I think this will be a good presentation, and it'll certainly make their explaining what you're going to see in the demo much more valuable. So I hope I got that correct, and we're going to turn it over to Robert Tabera from Airsight. Thank you. I don't see a clicker. Oh, there he is. All right.
All right, so welcome everybody. My name is Robert Tabera. I am the CEO of Airsight, a company that specializes in helping folks like yourself protect their airspace from unauthorized drones. Honestly, the presentations that I just saw, they're amazing. Paragon did a really good job explaining a few things that I think they're also part of my presentation, but they're also things that's very highlighted, is that this is a very difficult problem to solve. And you can't just click one click and buy a system and then your problem is resolved. This is a problem that's been going on overseas. We see this happen in Israel, where Iranian-made drones were still passing the Iron Dome system, some of the most complicated systems out there. And also we've seen that happen in Ukraine and Russia, where similar drones to these were used to kind of launch a lot of attacks. So this is a very complicated problem to solve, and that's how we should look at it. As this is a complicated, and we need to go take steps to go from step 1, step 2, step 3, and see maybe what we can do to help litigate some of the easier drones or drones that we can detect that are not as much complicated as some of the ones that we've seen out there. Another point that they made is that this is we have to do a lot of the testings yourself, just because obviously we're vendors, and this is very important for you to understand and test these systems yourself, to understand the limitations and have these communication between you and the vendors to understand what are the limitations of all these layers of systems out there, and how can you do it, what can you do forward to help mitigate them. So what I'm going to do here, I've got a whole bunch of things, but I think some of those you already went through, so I'm not going to go through them again. But obviously what happens with drones now, we have a third dimension of security, which is the airspace, and you guys have been doing a great job with ground security. A drone can come in undetected and launch an attack, drop a gun, etc. Why the problem right now? I think it's an important thing to mention, and really it has to do with the technology and the price. Before, in order for you to fly a drone, you have to be a drone hobbyist. You would have to invest a lot in learning of how to fly one. And usually those folks are not the folks that are going to be dropping contraband at your prison. What have happened in the last 10 years really with the introduction of DJI is that now anybody can go buy a drone out of nowhere with pushing a couple of buttons. This thing can hover. You can set it on a mission and it goes. So the technology went really high, and it made it really easy for anybody to go and fly these drones. And again, what we see here is very complicated, but again, that was the first step of the introduction of our drones into the airspace. The second thing is the price decreased. You can literally go on Amazon and buy a $2,000 drone, and that drone is able to handle 6-7 pounds worth of contraband. And just like Paragon mentioned, with a $35, $40 little connector that you can throw on it, you're able to now deliver that contraband into the prison. So very small investment, very easy to operate, and has very, very effective. This is one of my colleagues, that gun guy. What he did is he went into his garage and started kind of putting things on a scale and kind of understand what is this $2,000 drone can carry. And got a AR-15 and a full magazine, a Glock 19 with 150 rounds. So that's when it gets really scary, to kind of also go into a perspective to measure what is the amount of contraband or what is the weight of contraband in guns that this drone can carry. So another topic that was mentioned here is really important for you guys to understand really well is that right now, the FAA, just like Paragon mentioned, classifies the drone as an aircraft. So we have to treat it as an aircraft when we're doing any type of detection and mitigation. And the FCC has not allowed to the interdiction or mitigation of drone. So because of that, we now have to look at systems that we can legally deploy inside your facilities. And what these systems mean is that we're able to perform surveillance on these objects. We can create these geofencing based on different type of sensors that are available out there. And through this geofencing, we're able to detect that there's a drone in the air, ID, classify it, track it. And also what's important I'm going to show you here is you're able to collect intelligence similar to what the Georgia folks did that can help you with your investigation. What you're going to see here is I'm going to talk about layers of detection based on technology, not really vendors. I'm trying to make this type of presentation as educational as possible. So there's different types of technology out there that allow you to detect drones, and really it's come down to two things that has been very effective. One is hearing or listening to the RF frequency between the drone and the pilot and collecting whatever information legally that we can connect. In our layer one, which is a lot of vendors offer this type of technology, is legally collecting information that it's legally for us to collect, that we're not decrypting or creating any wiretapping laws that could be problematic with the FCC. Second layer of detection, this is called directional finding sensors. These are type of sensors that we're not decoding the system, the signal, but we're just really putting directional cones to see, here's a drone, we're hearing a drone is coming from this direction. And the third type of layer, which is also very important, is the radar and the camera. And that's kind of a catch-all type of solution where we're looking for everything that's flying in the airspace. And while that sounds great, and people would say, why don't we just do that and forget about the first layer and the second layer? There's always good information that comes out of each layer. And when we combine this information together, we get better results. So for example, an RF detection might be able to collect a drone ID or a drone tag or even a MAC address if it's flying over Wi-Fi. That could be very helpful to track the journey of that drone or that pilot over your state or over the entire US. Versus where RF could be very helpful with giving you the pilot locations in some cases, or at least the pilot direction, radar is going to be able to catch all, but then obviously one of the limitations is that you're not going to be able to see who's flying the drone. So that's another part of the advantage of disadvantage. So where we come in, we're saying our number one goal is to make sure we do everything in our power, whatever technology is available out there that we can deploy that will help you with your solution, knowing, again, there's also ways that you can bypass all these systems. Actually, in our presentation outside, we're going to discuss some of those ways, because that's the type of transparency that you need to have with your vendor to make sure that you're addressing the solution as much as possible. This is more of a slide to kind of show you the different type of technology, the different types of drones out there. So again, we've got the easier ones, the DJI now, especially with the introduction of the Aeroscope or the remote ID. These are kind of the easier ones that we can catch. The second ones are the Swell Pros that have been mentioned a couple of times now so far. Those are, will give you as a direction based on if we're doing the layer 2. And obviously, we've got the homemade drones, which you can see in both layer 2 and layer 3 type of solution. This is just a visual to kind of show you what are the systems that you're going to see out there when we're doing our demos. That's a radar, that's a sample radar setup, that's a camera, that's a DF sensor. Most of these sensors are passive, they're just listening for the signal coming in. The only thing that's active is the radar, and you would need to go through an FCC certification to get that installed at your perimeter. What I've got shown on here is really what your expectation to get when you have a layer 1 detection. If you have a drone that's flying on a layer 1 detection, that means that drone is transmitting information that's very, very helpful to you. This type of information includes, but not limited to, exact drone location with sometimes a 1 second or a 2 second refresh rate, altitude of the drone, speed of the drone, location of the takeoff of the drone, and also in many cases, the home location of the pilot. Because we're collecting all this information in real time, we can now draw actual geofences around the prisons, and we're able to know if this drone is across this geofence or is still across the street from it. This is the type of accurate information that we can capture if we are catching the drone using that layer. And one of the things that was mentioned earlier, it's actually part of the presentation here, is that they mentioned about the $24 app that you can get. Well, you can actually get it for free. Uh, so it's awesome because what you can do is you can go and spoof the location of your drone, and that's actually part of the presentation of what we've done to help with that spoofing or what we can do. But these are good scenarios. Is that there are ways to even hack these type of systems. One really funny story is that there's a YouTube video that's done by the Ukrainian soldier, and he was basically going over showing how to spoof that drone. And actually, we've seen this as another DOC, before even that video made it. But he was basically going in there and taking the GPS location of that drone and spoofing it to be the location of the enemy. So that's what they're firing their missiles to, or what they're trying to shoot the drone down. And in some cases, he said you can even make it Moscow if that's what you want to do. So these are different ways, unfortunately, you can spoof the system. And that's why, again, going back to the layered approach of why we stack systems on top of systems, is because we're kind of in a spot that nothing really 100% work, and we're just throwing whatever we can at it and collecting that information and mixing and merging that information in so we can get something better out of it. And that's really, unfortunately, our best solutions as of right now. Other things that we have done in the past that's been very, very helpful is that we don't delete any data. Data is king. I mean, a guy that pops in one state could pop up in another state, and connecting these dots together really go a long, long, long way. Sometimes it happened only actually one time where we actually had someone spoof the drone ID with like the yen type of thing. So we've seen even spoofing of that type of system, but this have really helped us kind of become proactive or help our customers become proactive, because if they have flagged a drone in one location and that drone makes it to another location, we can give them that information in real time and help them understand kind of what's going on here. Another things that we do, maybe not super fit for a correctional department, but we try to understand the mindset of the pilot. Is he the pilot that flies 1,500 feet above the air? Is he the pilot that flies beyond visual line of sight? So we collect all this data based on that drone ID, and we show you here all that information, and all this stuff is happening in real time, which could be very, very helpful when you try to make decisions of what to do. Especially, again, we talked about NFL, things like that. One of the things that when the NFL director told me one time, well, let's just say I have a drone over my stadium. In a prison, you guys are going to go to lockdown and secure the situation. But in NFL, let's say we evacuate everybody, and then the NFL the drone just zips to the other side, and then I'll get another problem on the other side. So different situations have different problems, and the way we look at it is sometimes that also changes what type of systems you deploy based on the environment that you're in. The second type of solution is directional finding sensors. That's the sensor that we're not decoding anything, but we're just saying, look here, look here. Paragon mentioned that in their presentation and said you should ask the vendor to look at the library. True, because the bigger the library, that means the more drones you detect. So that's obviously something very, very important. And when those sensors come out outside, as you'll see them, they'll show you a drone and say, I'm hearing a drone coming from this direction. I'm hearing a drone coming from this direction, etc. We're not going to be able to tell you exactly where that is. You can attempt to put multiple of those sensors together and triangulate. They tend to work much better in the prison environment because they're isolated locations and there's not a lot of RF noise. But try to put that in any type of downtown, you've got so much reflections and refractions that things don't really work well. But in your environment, there's a good potential for those things to work. And that's part of the RF study that needs to happen at your facility before anything gets deployed. This is a true story. About a couple of weeks ago, 2 a.m. or actually I think about 11 p.m., the signal goes off at night, says, hey, I'm hearing a Swell Pro coming from this direction. That's what a Swell Pro looks like. It's a drone with a built-in mechanism that again, you don't have to even modify or even try to add something. It's already comes built in. Radar sees the drone. Radar takes the camera to the drone, and that's the first time we made contact with that drone. That was about 700 meters away, 700 to 800 meters away. And then the AI layer kicks in. That's when we're trying to classify, what I'm seeing a drone or a bird? Because again, radar sees everything. That's the payload that you can see the drones flying, and that's now the system has properly classified the drone, and then obviously the folks at the facility are alerted. This is one of the radars that we're gonna show you outside as the Equidyne, and just I do this because I want to show you what does a radar camera tracking look like. I think a visual would really help. There's an example of an event that's been triggered by a radar, and every time we deploy a radar, we have to deploy cameras, or the system will just go off all day long detecting birds. We had one of the corrections that we're in is right across from a chicken farm. You can imagine all the birds and everything's around it. But that's kind of how some of this technology works, is basically combining these different technologies together to get something out of them. All right, another thing that we've kind of learned over the years is that in addition to just having technology, understanding kind of the psychology of what these folks do really also goes a long way. What we've seen in the past, and almost 90% of the time, when they like to take off, you can see the street right here where it says the home location. They're usually very close to the road because they want to kind of get back in their car and leave. And what they do is, you can see the graph here that we've outlined in our software. They kind of go up. In this case, they went up to 900 feet, and they fly straight in. And sometimes they try to attempt to do the drop right from that altitude, and that's why you see sometimes a drone drops on your rooftop. They just kind of aim wrong. And sometimes they drop because they want to be able to get it right. But then they fly back at the same altitude, and right when they reach their car, they'll kind of come down, back, and leave. And this is not a one single case type of deal. I mean, we've got literally hundreds of different drops that we were able to capture, and they're pretty much very similar in the type. And that's kind of how we also kind of learn and collect intelligence, by understanding some of these things. It takes time to build and understand how all these things work. Similar, this time he's at 754 feet. And in this scenario, he was actually hiding in the bushes. This was one of the only ones that he was a little bit off the road. But similar, he's going to a specific spot. They've already done all the coordination. They just come back. Now, a really, really important thing that I would like to mention is that I would say, regardless of what do you buy and what do you do, I would say 65% of it is technology, 35% of it, in order for you to have an effective drone countermeasure system, is keeping humans in the loop to understand what's happening. And that human in the loop helps not overwhelm the client with too much. I'm not going to say false detections, they're real detections, but they're not threatening detections. It could be a little Jimmy across the street that bought a drone and next to the prison is flying up and down, causing the system to go off, or birds in your area. So what we've done, which is something I think unique to us, I know it's unique to us, is that we have a 24/7 monitoring sensor system that looks at all the detection as they come in, and we have a way of analyzing them before we alert our customers. So the first thing, for example, we look at it, that's the easy one. Did the drone cross the geofence? That's an easy alert. The second thing we look at, if we have a directional finding sensor, that's the layer 2 that I mentioned, is going off, we wait till at least 2 to 3 minutes to make sure it's valid, it's not a garage door opener that somehow we thought it was a drone. And then we escalate a plan. And we also have learned that, even though we have we've seen some drone drops, in the morning, most of them, they come in between 7 p.m. and 7 a.m. So all these different things that we apply to help filter out a lot of the noise. Another thing that, while it also is very important, is that the feedback that we get from our clients are as equally important. If a client have a drone that crashed into their yard and we did not detect it for whatever reason, having that communication and that transparency between the client and the vendor, and honestly, it should be more of a partner, goes a long way, because then now, we're on the same team, and we want to make sure that if this drone comes again, we're able to detect it. And in some cases, we go out there and we put up another sensor, and it's constantly learning. because we want to be able to see, can we catch this drone the next time it comes in and see what we can do about it. All right, so the last thing that I'm going to talk about here is just whatever we're going to see outside. It's going to be pretty quick. The first thing that we're going to do outside is simulate a drone drop. I think it's very helpful to kind of just see how does a drone drop look like. So we're just going to fly and drop it, and it's going to be that simple. Case number 2, we're going to do a drone swarm. We're going to set out 4, 5, 6 drones out there and just see how do we deal with multiple drones at the same time. The third case is actually start to show some of the issues or vulnerabilities with these systems. We're going to actually fly a drone under the radar. One of the things that, where radar kind of struggles is that radars are really aimed to look up maybe a 10-degree pitch or a 5-degree pitch. If you're kind of flying right on top of the fence, then you're kind of missing the radar detection, and that's just part of what we explain and some of the limitation that we have. And then again, that's like one of the main reasons why the Iron Domes and a lot of the complicated systems out there are not detecting those slow-flying drones coming in because of that reason. Fourth thing we're going to showcase, that the myth is that if I can't hear it and I can't see it, it doesn't exist. We're going to be able to fly multiple drones, and you're not going to hear them, you're not going to see them, but we're going to be able to track them on our software. This is something important for I think for you guys to know. Case number 5, if we're tracking a drone with our layer 1, we're going to show the capability if you can actually track the location of the pilot. If you start running, you'll be able to kind of follow him. So really more and more intelligence. The case number 6, we're going to actually showcase how a non-RF drone is being detected by the radar, and that's the only detection system that's able to detect that drone because it has that capability. In case number 7, we're going to go through just all the historical data and analytics that you'll be able to kind of go through the system. That's all what I got, but I just want to show you one more thing. This is part of the presentation that I kind of kept at that is the spoofing. So again, these are things that we try not to hide. We actually kind of do some of those tests ourselves. You can buy that app. You can actually just put foil paper on top of the drone itself, and it's no longer transmitting a GPS. So part of the education that we do is we go through also what are the things that we can do, and then work together on how we can solve them. So that's everything I got. Thank you, everybody, for having us.
Excellent. Well, good morning, good afternoon, everybody. Happy to be here. Great presentations all day this morning. This was very insightful, and thank you guys, Robert. I wanted to share a little bit from the Echodyne perspective, from the radar portion of this. I've been working in critical infrastructure, protecting all sorts of different sites for about a decade, and I'd like to offer some value to you guys from what I've seen, even within corrections and from some other markets as well. Let's see. All right. So first, why radar? As we're talking about this detection system. So as we've seen and we've heard many times today, the threat landscape is rapidly changing. We're seeing that across the board, internationally and in the U.S. As I'm looking at these drones in front of me, it's rather scary. The risk started with the crazy, clueless, careless drone operators that might accidentally fly over an event or into an area that they weren't supposed to be, but they might not have realized that they weren't supposed to be there. But as time goes on, as more deterrents like geofencing and legislation is put into place with those no-fly zones we talked about a little bit earlier, there'll be more prosecution, more capabilities there. So the clueless and the careless and even like the compliant folks that have Part 107 licenses, that whole side of the spectrum is going to begin to be taken care of by some of those base layers. So really kind of like that chart that you shared where that smaller percentage, it used to be, a very small percentage of all drones out there were being used for nefarious purposes, but more and more so, unfortunately, we're seeing that start to kind of shift the other direction, where it's within that top of the triangle where the bad actors, the criminals, the cartels, the sophisticated actors really sit in that peak. And so the criminal, the combatant on that far right side is more and more going to be the threat that we need to account for. And when we think about the timeline as well of testing equipment, deploying it across numerous sites, it can be a pretty long cycle. And so I think one thing that I'm kind of considering just sitting here is how soon are we going to see more of this in other states, and how often are they going to be more sophisticated? Is it 3 months out? Is it 6 months? Is it a year? Is it 24 months? And think a little bit about the cycle of testing and deploying, because if as radar systems are required to see the ones that are hardened or that are flying with fiber optic cable, as you've probably heard from overseas, they just connect a cable to it, so they're flying actually plugged directly into the drone, so there's no signal going between the drone and the pilot, for example. So there's a whole lot of technology coming out very quickly. How soon are we going to see that in mass here? It's probably sooner than we think. So I just want to encourage us, at least in terms of what we want to think about today, is making sure that the technology is vetted and tested. That's going to account for what's coming out sooner than later. So I alluded to this. The threat really is becoming more and more these dark drones that are flying invisible or silent to passive sensors. I'll show you a quick video of one that there was 3 separate technologies set up to listen for the drone, and none of them picked it up, but the radar cued a camera at a real site here not too long ago, and you could see that drop actually take place with the camera side, but then also on the radar portion. I'll show you a screenshot in a little bit, but the radar's picking up the track actually, and Robert showed an image of that as well, where the track was popping up, and metadata around that, where the drone came from, where it left to as well. So as we look at radars, not every radar is created equal, and a lot of the technology that you'll see today from legacy radar systems that were originally used for detecting people jumping over fence lines, because that was just more so how we saw radars being used over the last couple decades in critical infrastructure. They were originally designed to see a person. The size of the target is fairly large and can't move extremely quickly and stays on a very level elevation, as you can imagine. So it's kind of a two-dimensional scenario, and a very big shiny target essentially to a radar to be able to pick it up. So the sensors didn't need to be designed the same way as when you start to look three-dimensional, and you're looking at an extremely small, nimble target really far away, and now you're looking at X, Y, and Z. So we'll get into it a little bit, but I want you to keep in mind the underlying technology. What was it developed for originally? Because again, the timeline of trying to develop a new system can be pretty long or lengthy. So why Echodyne? Why are we in this space? And so originally, we looked at what was in the nose of the fighter jet, the electronically scanning array radar, phased array radar. It's the gold standard of radars looking in the airspace at flying targets. And you can kind of see a little bit on the bottom right there, all sorts of hundreds and hundreds of these antenna elements, all these little dots on there. And it's really big, it's really power hungry, very effective, but it's just extremely expensive, military grade, military priced, right? And billions and billions of dollars have been spent trying to figure out how to solve this challenge and make it smaller, lighter, more accessible. Until Echodyne and the team out of a think tank created a new technology using metamaterials. Here, I'll go back one. And so they were able to shrink the size, weight, power consumption of those antenna elements. If you'll notice that to the far right, the second one in, you'll see the top antenna element, or the top antenna and the bottom antenna, and you'll notice all these little dots on those. And each one of those is an element. I won't get super deep into how the technology works, but the size of the panel itself is, as you can see on the far left, the size of a small tablet or book in your hand. It's like 2 pounds. So massive reduction in the size, weight, power consumption. So that military grade, military precision, military accuracy, we were able to capture and make it accessible to the commercial market. And we designed our system for the air first, starting about a decade ago. So we've been in this space for quite a long time. And then you can utilize our technology to see throwovers, like ground, people walking up to the fence line as well. But our technology was originally designed for that high precision 3-dimensional element. A quick example of why this matters is all of our antenna elements, we can concentrate the energy of a few hundred at the same time and form a super narrow beam. And a little visual for you up there is those beams can then form around really small targets that are really far away and lock in a camera at super far distances, so you can get, as Robert mentioned, that dual verification and classification. On the bottom, I'm showing a quick reference to the fact that if the beams were wider, like on the ones that are designed, the radars that were kind of the older technology designed for seeing a person, for example, they didn't need super narrow beams because the targets weren't really narrow. The problem is the further out you go, the further away from that target, the further the spread is of where that target might be. And the classic analogy is like a flashlight, just a standard flashlight you can imagine. The beam is super wide. It just keeps going out and widening and widening. That's much closer to the older radar technology for ground. Ours is more like, almost not quite a laser, but more like a flashlight, if you've seen it, that you can kind of tune in and actually adjust the field of view so you're honing in all of that light. In fact, my iPhone, I just had an update where I can actually take the flashlight on it and you can actually change the field of view if you've ever tried that. It's kind of fun, but it allows you to actually focus all those photons, all that energy into a very narrow spot and get a much brighter target, essentially. So a quick video here of what that looks like. We're firing off these really narrow beams all over the field of view and sweeping until we see a little bit of movement. Then we'll assign additional beams around that target using the resources on this small panel intelligently. It's a cognitive radar, so all the intelligence goes into where to send the beams, load around the target, and then we can classify, is it a drone, is it a bird, an aircraft? You get all sorts of metadata on speed, altitude, elevation, and all of that can be recorded as well to be able to go back and forensically look at the actual geotag of where it came into the field of view of the radar, where it left. And it was mentioned earlier that a lot of these pilots are taking off from one place and then moving and then landing their drone in another spot. So the radar is going to see that immediately, the direction it flew in versus the direction it flew out. And be able to, again, queue up that visual verification so that you have an idea of the payload as well. A little bit there on metadata, but I didn't want to get too detailed into it, but altitude, range, size, velocity, heading, bearing, on and on and on. And then at the bottom, you'll see a little bit of numbers, if you can read it, on probability of the classification. So we're saying, hey, that's 20%, 30, 40, 50, 60% a drone versus a bird versus an aircraft. And since we're a software-defined radar, we're constantly pushing out updates, and our ranges are extending from what we have on our data sheet. Our capabilities to classify are becoming more and more granular with every release, which is pretty exciting as well. And we need that. We need to be nimble as the threat changes. Maybe they start flying more larger fixed-wing drones, for example. They look a whole lot different, and they fly differently than one of these, right? The quadcopters. So our system needs to be able to, again, make adjustments, push out updates, and allow you guys to see the new and emerging threats. Radar is a fundamental layer of a security system, whether it's for counter drone or for picking up targets on the ground as well. And one thing I want to mention to you guys actually is we work a lot in other spaces where we help enable drone pilots to fly, whether it's police for drone as first responder programs. That's a big one that's moving rather quickly. And they want to be able to fly their drones beyond visual line of sight, so they don't have to keep an eye on it necessarily. But the only way to be able to do that, and I'm kind of cross-pollinating here a little bit for food for thought for you guys, the only way to be able to fly beyond visual line of sight and get approvals for that in these areas where you're going to fly over people in neighborhoods is to have surveillance, some sort of detection capability. And our radar systems are actually being deployed to enable those who have their own drones to be able to fly them beyond their visual line of sight, much further out. So as I've been working with a lot of correctional facilities, it seems like almost every single one is deploying their own drones in reconnaissance and for surveillance and to maybe sweep the rooftops or go look for contraband. With a radar system in place, like with Echodyne, since the FAA knows us really well in that other space, you could actually use that system to detect drones coming in, but also to submit a waiver to the FAA to ask for approval to fly your own drone, as long as the radars are actually seeing manned aircraft in a couple miles out, like they'll see Cessnas, helicopters, GA airports, or whatever else is going on. And if the FAA says, all right, you've got Echodyne radars up, you can see out to this range, then you can apply for approvals to actually fly your own drone out and actually utilize the radar to tell your drone which direction to go and start to kind of get into the future a little bit and double task the technology intelligently. And then of course I mentioned it, but you can also task them to see the ground targets of people coming in for throwovers as well as up in the air at the same time. So it's multi-mission and can really become a solid foundation for all the other sensors and queuing and cameras and everything and sensors that you have going on. So I kind of alluded to that here, just a stack of different technologies are really important. Robert hit that really well, so I won't belabor that. And the theme of I'll close with this, but the theme of Echodyne's kickoff for the year, which was just the last few days here, was the future is now. And I really do feel that sense. I mentioned it, but with these drones sitting in front of me right now, and what we're seeing overseas and what we're seeing happen all over the place, or what we heard in New Jersey, right? That was a huge frenzy. Everyone's brought it up. It was a big deal in the news. I don't want to get into a bunch of hype or conspiracy theories, but the fact is the biggest problem was very few people had the tools to be able to detect and actually validate what they were seeing, whether it was a drone or a helicopter or stars or birds or whatever. And so, man, that created a massive frenzy, right? And so I think the importance is, or it's just really important to understand what's coming, and if we're actually preparing for it appropriately over the next 6 months, year, 2 years, so that we can account for the unknowns and actually have that clarity. I'll mention one thing that was kind of mentioned to us this week in our kickoff from someone that we work with overseas. And he said that we need to think about how fast these types of drones are going to be coming, especially in Europe. They're thinking about this a little bit more heavily than we are at the moment, but there's actually 2 million drones per side right now over in the conflict. So 4 million drones that are this caliber, or FPV drones, or the different drones that are RF hardened, that are invisible to passive sensors. 4 million of them in 2025 between the two sides that are being deployed, and thousands of FPV pilots trained in these war zones. And they just gave us food for thought. They're like, what happens when that conflict ends, or when these guys get bored and they start thinking about what do they want to do next with their life? Well, that's 4 million more of these drones that are potential. And again, I'm not trying to strike fear and try to push you guys in that direction, but I think it's just worth considering. That little triangle at the top that we call 1% of drones, they're pumping them out in 4 million at a time already. And so I just think we need to be at least not slow to get ahead of the curve and actually make those considerations. So with that, I'll close out, but thank you very much for having me, and feel free to reach out if you have questions. It's a little rather small there. There's my email, phone number, but it's David Lewin. You can also look me up on LinkedIn, and I try to put out podcasts and food for thought and conversations with folks as much as possible on there to help educate in these topics. So thank you so much, and I'll turn it back over.
Thank you, David.